signing request. So we're making a request to sign or generate going to serve as our workspace. We're going to log into that server, and that's where we're going to generate the certificates that we need. Down here in the instructions, you can find more information about the simulated environment that we're going to be generating these certificates for. So we're going to pretend that we have 2 controllers and 2 worker nodes. And here are the host names and IP addresses that we're going to assume for these nodes in order to generate the proper certificates. We have 4 tasks here, and if you look at these question mark icons, you can click on these icons. You can actually find the commands that you need to do in order to complete these tasks. So if you get stuck at any point in the learning activity, feel free to check out these commands. You can just copy and paste them if you want to, but it's a good idea to understand what's going on in each one of these commands. And I'll be explaining that a little bit as we go through this solution video. So the first thing I'm going to do is I'm going to go ahead and get logged into my server. So I'm going to copy the workspace public IP right here. And I'm going to use these 2 credentials, this username and this password, in order to get logged into that server. So here I have my command line, and I'm going to get logged into my server. I'm going to do SSH cloud_user, that's my username, at that workspace public IP that I just copied. And of course, I'm going to type yes here, and now I need to enter the password. And I'm just going to go ahead and enter that password that was on my learning activity page. So now I'm logged into my server, and the first thing I need to do is I need to generate the certificate authority. And the certificate authority is essentially just a normal certificate, but it's going to be used to sign the other certificates that we're going to create. And different components of the Kubernetes cluster can use that certificate authority to determine whether or not the certificates that we create are genuine. So the certificate authority is used to generate the certificates, and later on, it can be used by various components in order to determine their genuineness and ensure that we don't have any false certificates being submitted. And that's how we're going to ensure secure authentication for all the different components of a Kubernetes cluster. So we're going to generate the certificate authority, and I'm just going to use this command. I'm not going to make you watch me type out the whole thing. And it's okay to just copy and paste from the guide, but it's a good idea to understand what's going on here as well. So I have these curly braces, and that's just allowing me to enter multiple commands all at once. So all these commands are going to be entered as part of a single large command. And what I'm doing here is I am generating a file. I'm generating a ca_config.json file, and this is going to be the contents of that file. So this is the configuration file for my CA, or my certificate authority. And there's just a bunch of different settings here about what that certificate authority is going to look like. Then I have a ca_csr.json file, and CSR in this case stands for Certificate Signing Request. So we're making a request to sign or generate a new certificate with this metadata here. And this certificate in this case is actually going to be our certificate authority. And then I'm using cfSSL gensert, and cfSSL is what's going to generate our actual certificate, and we are passing it that certificate signing request, and then converting that using cfSSL JSON into an actual certificate. So let me just go ahead and run this command. And then if I do an ls, you can see that I now have several files here in my home directory. Of course, cacsr.json and caconfig.json are those two files that I created as part of that command. Then cfSSL generated my actual ca.csr, that's my certificate signing request. And finally, I have my cakey.pem and my ca.pem, and these are the files that we really care about. Ca key is the private key, or the private portion of my certificate authority, and ca.pem is the public certificate that's part of my certificate authority. So everything we just did was really done just to generate these two files here. So that's all it takes to do the first task, which is provisioning the certificate authority. Now we are ready to generate our Kubernetes client certificates. Client certificates are certificates that are used to authenticate. So you can think of a client certificate almost as a more secure version of a password. It's used for basically the same purpose as a password. So different components of Kubernetes are going to authenticate with each other using these client certificates. And there's a series of them. If you expand this, you can see there's actually quite a few commands that we need to run in order to generate all of the necessary client certificates. So I'll go ahead and show you how to do that now. So the next thing I'm going to do is I'm going to generate the admin client certificate. And this is just a client certificate for the admin user. So any Kubernetes components that are using this admin user will need to use this client certificate in order to authenticate. And I'll explain what's going on in this particular command. Some of the later commands are doing basically the same thing. So I'll explain this one in a little more depth, and that explanation will kind of hold true for some of the other commands that we're going to do as well. Again, I'm generating a certificate signing request and then doing a gensert, but this time I'm passing in my certificate authority. So this certificate is being signed by the certificate authority that we generated earlier. So I'm going to go ahead and run this command. And as you can see, I now have an admin key.pem and an admin.pem. So there's my two certificate files that I just generated. So now I'm ready to go ahead and generate my kubelet client certificates. And as you can see in this command, I'm actually generating two different certificates. I've got two cfSSL gensert commands here. The first one is for my first worker node. If you look back at the instructions for this learning activity, you can see that I have two workers, worker 0 and worker 1. This command is basically the same as the one we used to generate the admin client cert, but I have added a host name in here because this particular certificate is specific to a particular host, and that's worker 0, and there's the IP address for worker 0. So this client cert will only work for this particular host. And then, of course, I'm generating a second certificate for the second host, which is worker 1. So we're just generating certs for kubelet, one for each particular worker node. So I'm going to run that. And if I do an ls, you can see that I now have my worker0.mylabserver.com.pem as well as the private key. And I have the same thing for worker 1. Worker 1, mylabserver.com.pem, and the worker 1 key. Next, I'm going to generate the certificate for the Kube Controller Manager. And Kube Controller Manager is just a component of Kubernetes, and this is the client cert that that component is going to use. This is pretty much exactly the same as our command for the admin user, except we're doing Kube Controller Manager instead of admin. So we have a different username, and we're going to go ahead and generate that cert as well. And you can see I now have my Kube Controller Manager key and my Kube Controller Manager PEM. Next, I'm going to do Kube Proxy. Again, this one is almost exactly the same as Kube Controller Manager and our admin user, except it's Kube Proxy. So this client cert will be used by Kube Proxy, which is just yet another component of the Kubernetes cluster. And I've got my Kube Proxy key and my kubeproxy.pem. And last but not least, I'm going to generate a certificate for Kube Scheduler. Just like Kubernetes Controller Manager and Kube Proxy, that's also just a component of the Kubernetes cluster. So I'm generating one for Kube Scheduler here. And I have my Kube Scheduler key and kubescheduler.pem. So that was probably the largest task that's part of this learning activity. We've now generated all the client certificates for the different components of the Kubernetes cluster. Now we need to generate a Kubernetes API server certificate. And we can do that with this command right here. And I'll go ahead and paste in our command. And this one's a little different. This is not a client certificate. This is a server certificate. And it is used by the Kubernetes API server. This is basically our TLS certificate that allows different components of Kubernetes to access the Kubernetes API securely over HTTPS. As you can see, there's a long list of host names here, and this is pretty important because this host name includes all the various host names and IPs that different components of our Kubernetes architecture might use in order to reference the Kubernetes API. For example, this IP address is what could be used by internal applications or internal pods to access the Kubernetes API internally. And that's just a standard that's used in a lot of places, 10.32.0.1. So this is the IP address that's going to appear in our internal Kubernetes network, and therefore we need that IP address to be signed within this certificate. I also have the IP address and host name of my first Kubernetes controller. If you look back at the instructions to the learning activity, you'll see we have 2 controllers. And here's the IP address and host name for the second controller. So if any components of Kubernetes are accessing the Kubernetes API directly on either of those controllers, the certificate needs to be signed with that IP address and that host name. Otherwise, things are going to fail because the server does not have a certificate that is signed with the IP or the host name that's being used to access that server. And this third group is part of the load balancer. So we're assuming that we're going to be using a front-end load balancer on top of the Kubernetes API. So if anything accesses the API through that load balancer, this certificate needs to reflect that as well. So we have the IP address and the host name of the load balancer. And then there's many instances where various components of Kubernetes might be accessing the API locally. So we need the default local host IP of 127.0.0.1 and the host name of localhost, and also Kubernetes.default, which is just a internal Kubernetes host name that may be used to reference the Kubernetes API server. So I'm going to go ahead and run this command. And that's going to generate our Kubernetes key.pem and our Kubernetes.pem. Now there's one final task that we need to do. We need to generate a Kubernetes service account key pair. Of course, we've got a command for that here. I'll go ahead and paste in my command over here. And what the Kubernetes service account key pair does, this is a certificate that is used to sign service account tokens for Kubernetes service accounts. So when Kubernetes provisions service accounts, it's able to generate tokens that can be used to authenticate with those service accounts. And it will use this certificate key pair in order to sign those tokens. It's just something that's needed as part of the baseline Kubernetes setup. So I'm just going to generate this cert. And of course, we can see that I have my service account key.pem and my service account.pem. So now I have generated all of the certificates that I would need in order to set up a basic Kubernetes installation later on. And that's all I need to do in order to complete this learning activity. The next time this server restarts. So if the server restarts, that value is no longer going to be set and my networking is not going to work appropriately. So to make that change permanent, I need to write that value to sysctl.conf. And I'm going to do that just with an echo, and I'll echo the line that I want to write to the file. And the name of the value is the same as the name that we used for sysctl. It's just net.ipv4.conf.all.forwarding. And then I just need to put =1. And I'm just going to echo out that string. And that's going to be the line that I'm going to write to my sysctl.conf. So I'm going to pipe that. And I need to use sudo to write to that configuration file. So I'm going to do a sudo t-a to append this to the end of the file. And I'm going to append it to etsy/sysctl.conf. So now I have successfully enabled IP forwarding on both of my worker nodes, and I'm done working with the worker nodes. So at this point, I can go ahead and just close this terminal window. To do the next task, I need to log into the controller. So I'm going to copy the public IP for the controller, and I'm going to go ahead and get logged into the controller. So now I'm logged into my controller, and installing WeaveNet is actually pretty easy. I'm just going to paste in this command so that you don't have to watch me type out this URL. But I'm just going to do a kubectl apply-f. And Weaveworks, which is the group that makes WeaveNet, they provide this service that generates configurations we can use to install WeaveNet in Kubernetes. We are passing in our Kubernetes version here, as well as our cluster CIDR, or the IP range that we want to use in order to allocate to pods within our cluster. So for us, that's going to be 10.200.0.0/16. And this is going to download a file that's configured appropriately, and then we're applying that file with kubectl apply-f to go ahead and create our WeaveNet configuration. And as you can see, It has created several endpoint URL. I don't need the port because it will assume port 80 by default with curl. So I'm just going to go ahead and enter that IP address of 10.200.0.2. And I got exactly what I expected. I got some HTML output that is coming from my Nginx server. As you can see, the title says, "Welcome to Nginx." That means that I was able to successfully connect to that first Nginx pod over the pod network. Now I'm going to copy this second IP address, and I'm just going to repeat that command that I just did, but I'm going to use that second IP address for the curl. So I'm running a curl command on that second IP address inside the BusyBox pod, and I got the same output. So we were able to successfully connect to our Nginx service on both pods. And that's important because we have 2 worker nodes, and 1 Nginx pod is running on each of those nodes currently. And the fact that I'm able to connect to both shows me that I can connect to pods that are on the same worker node as the BusyBox pod, and we can also connect to pods that are on a different worker node. And that's just showing that our network setup is functioning the way that we expect. So the last thing we need to do to verify our network configuration is we need to make sure that we can connect to our service. So we've connected directly to each pod. Now we want to connect to the service. So I'm going to do a kubectl get svc for service, and that's going to list out my services. And I can see my Nginx service right here, and this is the IP of that service. So I'm going to copy that IP and make sure that I can connect to that IP from inside the BusyBox pod. So I'll just do a kubectl exec again, and I can reference that pod underscore name variable. And the command I'll run is just curl against that service IP.
Welcome, and in this video, I'll need to copy my public IP address and paste it in. The username is going to be administrator, which is the default Windows administrator username. And then again, we'll need our password. I'm going to copy in my password, close it out, double click on it, select continue, and we are going to connect to our Windows instance.
You have 5 minutes remaining.
As you can see here, I'm logged into the Windows Welcome, and in this cloudassessments.com learning, AWS knows that we may want to IP address ranges. Now, as we discussed, we did create a public IP address stop the instance. Now, in order to ensure that it's not different when we start and stop the instance, let's go ahead and worry about updating our DNS. So what I'm going to do is I'm going to head over to the left-hand side under Network and Security and cent per hour if you have elastic IP addresses that are not associated to something in your account. If it is associated to something in your account, you are not charged for it. So now that it's associated on here, in order to demonstrate that it works, we can go back to EC2 instances and view that our elastic IP address has actually replaced our public IP address. It's also replaced our public DNS. So if I want an address, I'm going to select the left-hand side under Network and Security and select Elastic IPs. I'm going to allocate a new address. It's going to be allocated to my account. So I'm going to select Close. Now, this is my elastic IP address. Now, it's not in use. I can associate this to an Elastic Network interface. I can associate it to an EC2 instance. So I'm going to select associate.mywebserver.com domain to this instance. We would want to use that elastic IP address. That way, if we ever changed resources in or on the back end, we don't have to worry about updating our DNS. So what I'm going to do is I'm going to head over to the left-hand side under Network and Security and select Elastic IPs. I'm going to allocate a new address. It's going to be allocated to my account. So I'm going to select Close. Now, this is my elastic IP address. Now, it's not in use. I can associate this to an Elastic Network interface. I can associate it to an EC2 instance. So I'm going to select Associate Address. I'm going to select it to the EC2 instance. I'm going to select my already existing Windows Web Server Anthony EC2 instance and then associate it. Now, please note, you are charged 1 cent per hour if you have elastic IP addresses that are not associated to something in your account. If it is associated to something in your account, you are not charged for it. So now that it's associated on here, in order to demonstrate that it works, we can go back to EC2 instances and view that our elastic IP address has actually replaced our public IP address. It's also replaced our public DNS. So if I wanted to launch a duplicate one of these, because maybe this instance failed, and I wanted my website to point to here, I would just unassociate the elastic IP address and reassociate it to the new instance. Now, to also demonstrate that this works, here's our prior one, which no longer works because it's going to a DNS name that doesn't exist. So let's paste in our new elastic IP address. And I wanted my website to point to here, I would just unassociate the elastic IP address and reassociate it to the new instance. Now, to also demonstrate that this works, here's our prior one, which no longer works because it's going to a DNS name that doesn't exist. So let's paste in our new elastic IP address, and you'll notice that here is our website being served from our web server. So that's why we should use elastic IP addresses. There's lots of other use cases, but specifically from this use case of working with a basic website, that's why and how we would use it, and a little bit about how they would work. And one other quick note, you do not need to have elastic IP addresses if you're using a load balancer. So we learned a lot of basics about working with Windows inside of Amazon EC2, and we've learned about how EC2 instances work. Now, we've learned a little bit about elastic IP addresses. We learned different use cases with it, how to connect to our EC2 instance, and how to use user data as well. It's very important that we take these concepts and grow off of them, so continue looking for other AWS activities on cloudassessments.com. Also, check your checklist on your activity to make sure you completed all of the tasks required as part of this learning activity that ensures that you've gone through and performed the proper concepts hands-on in the provided AWS environment. So that concludes it. Go ahead and complete this activity and find another one. Use cases with it, how to connect to our EC2 instance, and how to use user data as well. It's very important that we take these concepts and grow off of them, so continue looking for other AWS activities on cloudassessments.com. Also, check your checklist on your activity to make sure you completed all of the tasks required as part of this learning activity that ensures that you've gone through and performed the proper concepts hands-on in the provided AWS environment. So that concludes it. Go ahead and complete this activity and find another one. Welcome.
Welcome. In this lab, let's go to security group, then we can go to review and launch, and we'll select the exact same key pair, acknowledging that we have access to it, and then we'll launch the instance. Now if I click on the instance ID, we'll see that it's in a pending state. Now we have to wait for it to initialize, configure all of that, and then once that's done, we'll be able to grab its public IP address and pull up the exact same test page because it will have the exact same software. Dedicated to this instance, public IP address, open a new tab and paste it in there, and we get the exact same Amazon Linux AMI, very first AMI, because AMIs are crucial to use the same AMI region. We could rename the AMI if we wanted to. We could also give it a different description, and we could also encrypt the AMI if we would like. Now, I'm not going